We'll start with 15th question. Here the question given is integration dx upon x raised to 4 minus 1, right? So I can factorize this as a square minus b square. If I write this as x square whole square minus 1 whole square, then I can write it as a minus b, a plus b. Now further, this can be factorized as x minus 1, x plus 1, whereas this will be as this. So I can apply partial fraction over here. I want to write this as a upon x minus 1 plus b upon x plus 1 plus cx upon d. Mind well, this is your quadratic term, so I have to write it as cx plus b. If I cross multiply this, then I will have 1 is equal to a into x plus 1 x square plus 1 b into x minus 1 x square plus 1 plus cx plus b into x minus 1 x plus 1. Now, if I keep x as 1, then 1 is equal to a into 2 into 2 plus this b and cd will get eliminated. I will get simply a as 1 by 4, right? If I keep x as minus 1, then here a and c and d will get eliminated. I will have just b minus 1 minus 1 minus 2, and this will be 2. So I will have b as minus 1 by 4. If I keep x is equal to 0, then I will have a minus b plus this will be minus 1, and I will have minus b. So 1 is equal to, I have the value of a, I have the value of b, minus minus will give me plus. So b is equal to 1 by 2 minus 1, which will give minus 1 by 2. Now I can keep any value of x as 2. So 3 into 5,
Hmm.
15a, 2 plus 1, 3, and 4 plus 1, 5. Here plus b into 2 minus 1, 1, and 4 plus 1, 5. That will be 5b plus 2c plus d into 2 minus 1, 1, and 2 plus 1, 3. The final equation is 15a plus 5b plus 6c plus 3. I know the value of a as 1 by 4. This is minus 1 by 4. 6c as is, and this is minus 3 by 2. So this will be uh, 10 by 4, which will be 5 by 2 minus 3 by 2 plus 6c. 1 is equal to 3 minus 5 minus 3, 3 by 2. 2 by 2 will give you 1 plus 6c. So 0 is equal to 6c. Value of c is 0. Right. I got all the values of a, b, c. I will keep that in equation here in equation 1. So we'll get, but now let's keep the value of a, b, c, d in equation 1.
हो गया सर ज्वाइन।
Okay. Now see, I will keep the values of a, b, c, d in this equation. So I will have 1 upon x minus 1, x plus 1, x square plus 1 as 1 by 4 upon x minus 1 minus 1 by 4 upon x plus 1 plus the value of c is 0. So I will have just minus 1 by 2 upon x square plus 1. Right. So if I take integration on both the sides, then integration dx upon x minus 1 x plus 1. So I have to take integration over here also. I will take 1 by 4 outside. I will have 1 upon x minus 1 dx. This 1 by 4 will come outside. I will have x plus 1 dx. This minus 1 by 2 will come outside, and I will have dx upon x square plus 1. So this will be log mod x minus 1. This will be log mod x plus 1, and this is of the form 1 upon x square plus b square, whose integration is 1 by a tan inverse x by a plus c. So if I take 1 by 4 common outside from first two term and apply the property of log, then I will have x minus 1 upon x plus 1 minus 1 by 2 tan inverse x plus c. This is your final answer. Let's understand the 16th question. It is integration dx upon x into x raised to n plus 1. So I will multiply x raised to n minus 1 in numerator and x raised to n minus 1 in denominator 2. So I will have x raised to n minus 1 dx upon here. Laws of indices can be applied, and the power of this x is 1. So minus 1 and plus 1 will get cancelled, and I will be left with x raised to n. Here x raised to n plus 1. So here I will use substitution method. I will substitute x raised to n as e. So n x raised to n minus 1 dx will be my dt. So x raised to n minus 1 dx will be dt by n. So I can replace this as dt by n, and here it will be t upon t into t plus 1. Now you can apply partial fraction over here, but this is bit easy. You can see that I can write this one as t plus 1 minus t, right? If I solve this t and t will get cancelled and I will be left with just 1. If you will apply partial fraction, then also you will get the same answer. Now if I divide this individually, then here t plus 1 will get cancelled, and here t will get cancelled. So I am left with this result. I can take integration. Integration of 1 by t is log mod t, whereas this will be log mod t plus 1 plus c. So if I apply property of log, then I will have t upon t plus 1 plus c. Be careful that our sum is not in the form of t, it is in the form of x. So I will replace this substitution. Uh, t is x raised to m upon x raised to m plus 1 plus c. This is your final answer. Let's understand 17th question. Here it is given integration cos x dx upon 1 minus sin x 2 minus sin x. So I will assume for sin x as t. So derivation of sin is cos x dx will become my dt. So if I replace the substitution, then I will have dt upon 1 minus t 2 minus t. So I can write 1 upon 1 minus t 2 minus t as a upon 1 minus t plus b upon 2 minus t. So 1 is equal to a into 2 minus t plus b into 1 minus t. So if I take a t and 1, I will have 2 minus 1 1. And if I take a t as 2, then I will have 1 is equal to 2 minus 2. A will get eliminated, and I will have 1 minus 2 minus 1 minus b. So b will be minus 1. So if I replace the substitution, then I will have 1 upon 1 minus t 2 minus t and 1 upon 1 minus t minus 1 upon 2 minus t. So if I take integration on both the side, then it will be integration 1 upon 1 minus t dt minus 1 upon 2 minus t dt. So integration of this being log mod 1 minus t. Be careful that the coefficient of t is minus 1. So I have to divide that coefficient over here. The same way here the coefficient of t is minus 1. So I will divide that coefficient. And this is log mod 2 minus t plus c. So this will be minus log 1 minus t minus minus plus log mod 2 minus t plus c. So you can see that if I apply laws of or rules of logarithm, then I will be having 2 minus t upon 1 minus t plus c. Be careful that you have to replace the substitution. The final answer will be log mod 2 minus sin x upon 1 minus sin x plus c. This is your final answer.